Right, the last part of the question then is part C. Now let's have a little read through this first just to really understand what's been asked of us. And again, sometimes this might not be given in a question, alright, but in more recent years it tends to come up quite a bit. It is proposed to upgrade the thermal properties of the above wall to meet the passive house standard by fixing expanded polystyrene to the external surface as shown. So in the sketch that's given kind of in the actual question itself, it has this layer of insulation that's fixed to the outside of the wall, alright, so it's an external insulation. Given the thermal conductivity of expanded polystyrene as 0.031 watts per meter squared Celsius, calculate the thickness of expanded polystyrene required to achieve a U value of 0.15. Alright, and again, watts per meter squared Celsius. Now, so that's the kind of key thing here we're trying to find out first, alright? So we need to see how much insulation do I need to put onto this existing wall to give me a U value of that, right, 0.15. And the only other information I'm given is the conductivity, alright, so this conductivity. So where does that come from? Well, think back of the previous part of it in part A, when you had your conductivity of concrete blockwork, you had your conductivity of your insulation. So that's what we have here again, right? So that we have the conductivity. Now, when we calculated the previous one for part A, we had also had the thickness. So we went thickness divided by conductivity, and we got the resistance. And then we got that resistance, and we went 1 divided by resistance equals U value. So really, that's what we're trying to do here. We're trying to work backwards to try to find out what the thickness would be. We have the U value, and we have the actual thermal conductivity of that expanded polystyrene, which again is just insulation. So let's have a look here in terms of how we go about answering that one properly. Well, the key thing that we need to remember when you go through this, you cannot take or add U values together. So I can't just say, well, the old house was 0.52 and the new house is this, and I take them away from each other, and that'll give me the U value I need to make up. You cannot add or take away U values. You must bring them back into being a resistance. Alright, and that's very, very, very important. You cannot add U values or take them away. You must bring them back into a resistance. So how do I do that? So to convert a U value to a resistance, it's just the opposite to how we did it before. So when I wanted to get a resistance into a U value, I went 1 divided by resistance equals U value. This way, I just repeat it the other way around. 1 divided by U value equals resistance. So that's all we're going to do. We take our U value and we go 1 divided by U value equals resistance. So we've now converted our new U value, which is 0.15. Again, that's given in the question, what we have to get to. And there's the old U value. Again, we found that in part A. That's the old U value. And we convert that one back to a resistance. So now we have the two resistances. So once they're when they are a resistance, we can then take them away from each other to work out what the difference would be. So here we go. We take this small one from the big one, and we end up with the difference in between. So that's the amount of resistance that we need to make up with our external insulation that we're going to apply on this wall. So that is the resistance. So again, if you were looking back, lads, again thinking of these tables, all right, in order for us to find the resistance, we went and did the thickness divided by conductivity equals the resistance. Where here we have the resistance, we have the conductivity from the question, so we need to now find the thickness. So it's the same thing, we're just working it from slightly different angle basically by using the formula slightly different. So we were used to having the formula as thickness divided by conductivity equals resistance, but I want to try isolate thickness on its own. So you can imagine what we've done here with that formula. Let me just write that down slightly again. So what I would have here normally would be thickness divided by conductivity equals resistance. So all I've done is I've taken the resistance across the equal sign to this side, and I've moved the thickness across. Now when the thickness and as the divide crosses over, it changes to a multiply. So that's the only difference we went now. So the sign changes. So that's all we've done. We've brought the R across, we brought our thickness across the other side. So now the formula becomes resistance multiplied by conductivity equals the thickness. I just plug in the information. So there's the resistance that we got from here, multiplied by the conductivity, which was given in the question. Alright, so equals our thickness. And again, I can just actually see here, I see a slight little mistake on my question here, 0.031. So just look at that. I'm making a change to that. 0.03, that should be a 1 as opposed to a 7. 7 would have been the original one up here. So 0.031 equals. Now I'd question that as well. That could have been a mistake on the exam paper. But we'll use the one that's given. So 4.744 multiplied by 0.031 equals so what I'm getting for that one there is 0.147 meters. So that in millimeters, 147 millimeters. So again, this one looks to be wrong because I had that down as 0.37, which again would have made up a difference of 30 millimeters, which is quite a bit in insulation, especially if it's if you're doing it over a full house. It costs an awful lot of money. So that's it. Thickness required then is 147 millimeters. And again, as that's calculating the thickness of material in order to improve the thermal properties or to improve the U value of an existing wall. Right, so that's part C.